Jeff Milton from VDOT, Virginia DOT. He's going to talk about the SHRP OR2 R06A. Jeff serves as the Bridge Preservation Specialist for the Structure and the Bridge Division of the Virginia DOT.
All right, thank you for that very kind introduction. I'm glad to be here today. I think we're having a good week so far. Again, I'm happy to be here to share with you a little bit about Virginia's involvement in the SHRP2 R06A program. So, first of all, what is SHRP2? SHRP2 is the second Strategic Highway Research Program, and it is a partnership that is sponsored by the Federal Highway Administration, AASHTO, and TRB. SHRP was created to find strategic solutions to three national transportation challenges: improving highway safety, reducing congestion, and improving methods for renewing roads and bridges. The renewal research filled gaps in the development to produce user-friendly tools so that innovative design and construction methods can be applied more broadly. It also tested objectively evaluated alternative methods to provide transportation agencies with information they need to deliver projects more rapidly. And the renewal research products simplified access to information. So, now what is the R06A component of SHRP2? This project identifies non-destructive testing technologies for detecting deterioration in concrete bridge decks. The first phase of this project created a report documenting and validating promising technologies, and the report graded and ranked the technologies based on results of the validations. And this report is available online, and it's a very good report which gives a very good overview of NDT methods for bridge decks. The SHRP2 Implementation Assistance Program was launched in 2013, and through 7 rounds of SHRP2 provided more than $130 million in financial support and technical assistance to transportation agencies across the country. Virginia is and has been involved in 3 of these projects. The topic of today's conversation, the R06A, non-destructive testing for concrete bridge decks. Virginia's also been involved in the R19A project, service life design for bridges, and the R06G project, non-destructive testing for tunnel linings. The lead adopter incentive was made available to help offset costs associated with product implementation and risk mitigation, and Virginia is a lead adopter in the R06A Implementation Assistance Program. Virginia received a $100,000 grant under the Round 4 Implementation Assistance Program, and we are utilizing this grant to apply NDT technology for the assessment of concrete bridge decks. And Virginia is implementing this technology in 2 different ways: rapid screening of deck condition for many structures, that is network level analysis, and also to develop detailed damage quantities on individual bridges, or project level analysis. We develop contracts for non-destructive testing to implement our portion of this technology. And these technologies included infrared thermography and ground penetrating radar. And 2 rounds of contracts are advertised. The contract documents contain some qualification requirements for those that were bidding on it. For the firms, we required a minimum of 5 years' experience performing the services that we were requesting. For the project managers, we also required a minimum of 5 years experience, and we required that the firm submit resumes for all of the project managers. The first contract included both infrared thermography and GPR, and this contract was awarded to one contractor on February the 27th, 2017. The unit prices for this contract I thought were very good. Both the infrared and GPR contract prices were 7.9 cents a square foot, plus we had pay items for traffic control and mobilization. The first contract included 6 bridges in 2 districts totaling 76,488 square feet. Then we also advertised a second contract. The reason we advertised two contracts was because of some internal discussions with our procurement friends. But again, the second contract was advertised to include two lots, one lot for infrared thermography and one lot for ground penetrating radar. We could have had the same contractor depending on how the bids came in, but as it turns out, we had two separate contractors, one for infrared and one for GPR. Lot 1 was the infrared thermography. This contract was executed on September the 12th, 2017. The deck area scan was 251,953 square feet for 19 bridges in 7 of our districts. The contract total amount was $17,992. Again, the bid prices, I think, were very reasonable. The infrared scans were 6 cents a square foot. And then, again, we had pay items for traffic control and mobilization. The Lot 2 was for the ground penetrating radar. Again, that contract was awarded on the same date for the same quantity of deck area and the same 19 bridges. And the total contract amount was $20,460. Again, I think we received very reasonable bids. The GPR scan bid was 6.5 cents a square foot. And again, we had pay items for traffic control and mobilization. So we were very pleased with the prices that we received to perform this work. The contract for Lot 1 certainly included some technical requirements. Among those, that the work was to be performed in accordance with ASTM D4788, using a vehicle that could scan at or near highway speeds, which we defined as 45 miles an hour or greater. Also required the host vehicle to be equipped with a high-resolution thermal camera or infrared camera. And again, we required the host vehicle to be be capable of high-resolution video photographic images, again, taken at highway speed. Contract required the test data be analyzed for defect features in the decks. And we defined defect features as anomalous regions, spalling, previous patching, delaminated and deteriorated concrete occurring at the top layer of reinforcement and above. We required the testing to be presented in a written report. And we also required the report include a plan view of the bridge showing the areas and quantities for all of the defect features. The technology used was the deck top scanning system, which is a mobile platform that can be loaded and mounted onto a vehicle. Here's a photograph of the vehicle that was used for the testing. Okay, here is a example of one of the plan views showing the infrared imagery with the legends on it showing the various categories of deterioration. And this is a slide showing the high-resolution photographs that we received, basically showing the areas of deck patching and spalling. Okay, contract Lot 2 was for GPR. Again, we had technical requirements in the contract. Work to be performed in accordance with ASTM D6087. Again, using a host vehicle that was capable of collecting data at highway speed. We required a multi-channel array of air-coupled or non-contacting horn antennas or a multi-channel array of ground-coupled antennas within close proximity to the bridge deck. We required the antenna to have center frequencies of 1 gigahertz minimum with 1.5 to 3 gigahertz preferred. Again, we required the contractor to obtain high-resolution photographs and video as part of the work. Again, we required the test data to be analyzed for defect features. In addition to the defect features, we also required cover depth survey using the ground penetrating radar. Again, the results were presented in the form of a written report. and including plan views showing the defect features and the apparent cover depths over the top mat of reinforcing steel. The technology used for the GPR was a dual 2 gigahertz horn antenna system manufactured by GSSI from New Hampshire. This is an example of basically the raw GPR data that was produced as part of the work. And this is one of the plan views showing the spalling and delamination maps. You can see that. And then this is basically, that slide didn't turn out as well as I had hoped. But anyway, that's basically a contour map showing the apparent cover depths. The results from the infrared and GPR scans, we are currently in the process of reviewing and comparing those scans to each other and to the element level inspection data that we have for the bridges that were scanned. This is just a example of a chart showing the results of the infrared technology. The contractor combined these into the AASHTO condition states, showing sound patches, minor spalls, unsound patches, and major spalls. And this is an example of the data from the GPR testing, where we showed apparent delaminations, patching, and spalling. And then this is for the same bridge, an example of the element level inspection data for the deck for that bridge. So what we've done is for these 19 bridges, we have combined a master spreadsheet which has these 3 groups of data for each one of the bridges that was tested. So the next phase of the work will involve comparing the results of the non-destructive testing scans with the results of conventional deck investigations for selected bridges. We do not have conventional deck investigations for all of the bridges, but we do have it for several. So we're really looking forward to comparing these results and seeing how the comparisons really come out. And how are we going to use, at the end of the day, how are we going to use the results of this technology? Our hope is to use the lessons learned from this contract to develop a standing statewide on-call contract for our districts to utilize in evaluating bridge decks. And we will probably take that a step further, and not just bridge decks, but bridges in general. What we envision is a contract that will include GPR and infrared, possibly impact echo for decks, conventional sounding, chloride test, half-cell testing, so that we could have basically just have a contract where if one of our districts needs to perform some testing on their bridges, they can call on this contract and have the testing done without paying the high cost of someone to interpret the data. This will be just to furnish the data, and then we can interpret the data ourselves. I'd like to thank you for your time and attention. This has been a very interesting project, and I have been pleased to be part of it. I'd like to thank my colleagues Adam Mateo from VDOT and Dr. Michael Brown from WSP for their work and support as part of this contract. So,
what did the traffic control consist of on the contracts?
It was basically a rolling lane closure. We did not allow any stationary lane closures. It was basically truck-mounted attenuator and shadow vehicles.
Was that for protection of public, protection of the vehicles, both?
Both.
Okay. So even though you had them going highway speeds, you still implemented that kind of traffic control for safety?
Yes, we did receive some pushback from the contractors on requiring that, but our traffic engineers insisted that they wanted that the shadow vehicles and the attenuators as part of the work. Now, as we get more comfortable using this technology, maybe it won't be necessary in the future. But for the first round, our traffic engineers decided that was the most appropriate method to use.
Do you think that you'll be able to draw a conclusion that one of the technologies is superior to the other one for your application, or perhaps that for certain types of scanning, one is a preferred to use one for one application and use the other technology for another application?
I don't know that I can give you a definitive answer at this point. However, these two technologies operate on different physical principles. The infrared, I think, is going to more closely resemble the results you would obtain from a conventional sounding, and the GPR is a more qualitative type analysis, which may more closely resemble the results of half-cell potentials. So I think the combination of the two technologies are going to be very useful. If all you're looking for is just how much delamination you have, the infrared may be the choice.
My name's John Hagert from Connecticut. I had viewed a demonstration project in which the GPR didn't capture the information properly, and it was determined that it was because of the air-coupled antennas as opposed to ground-coupled antennas. Did you find any interference from electromagnetic signals in the area? Sometimes in more urbanized areas you can get interference with the air-coupled antennas.
Not that I'm aware of, but that's a very good point. It's something I may want to discuss with the contractor in some more detail. Thank you for your question.
And if I could follow with one other question, did you get cross-confirmation between different testing procedures? For instance, with your GPR results, did you cross-confirm that with potential tests, cores, et cetera?
We have conventional deck investigations on some but not all of these bridges, and that's kind of the next phase that we're going to compare the results of our conventional deck investigations with the results of this non-destructive testing. And I'm very interested to see how those results are going to compare with each other.
That's what gave us the first inclination that the air-coupled antennas might not have been giving us the right results, because we tried to get some confirmation tests by other means, and we weren't getting good confirmation. So that's when we redid it with ground-coupled antennas.
Okay, very good. Thank you. I appreciate that. So did you perform any infrared, or was it just GPR?
Just GPR. We did have cell potentials and cores, as well as chain dragging.
Sure. Okay. Very good. Thank you.
One more question. When you get the results of this, you're looking at delaminations that may have already been patched, and as well as delaminations that aren't visible on the surface, or spalls that aren't visible, right?
Okay, right.
So when you review the data, are you able to analyze or document where the patches are, so you might have an idea of which patching materials are working or not working?
The high-resolution photography part of this is going to give us a very good idea of existing patches, if that's answering your questions.
Yep.
We are going through the same thing in Nebraska, and we received 37,000. How come we received 100,000?
I don't know. You'll have to talk to FHWA about that.
No. Okay. Now, my actual question: do you have a plan to own your the equipment, or you thinking you're going to contract it out all the time?
Well, VDOT does own a GPR unit. We do not own an infrared unit. I won't rule out that we might purchase an infrared unit. That kind of depends on that. That will be a ways off, but that would kind of depend on how we feel this results. I think for the immediate future, it'll be contracted. Thank you very much for your time and attention.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.